Hi all, good morning. Guys, am I audible?
Yes.
Hello?
Yes.
Yes,
Okay.
you are
Yes,
audible.
yes, sir. Audible.
Yes.
Okay. Thank you. Thank you. Let's wait for 2 minutes. Let's wait for other people to join, then we'll start. Right, I think we can start. First of all, good morning, good afternoon, all of you. Thank you for joining. So the idea is we are going to go
Good
through the
morning.
Kubernetes training. Hey, good morning. Yeah, okay. So let me share my screen. Let me know once it's visible. Okay. Can you guys see my
Yeah,
screen?
visible. Visible.
Yeah, it's
Okay.
fine.
Yeah. Thanks. Okay, let me start.
Hey, hi, Harkirat. Hey, guys. Thank you for joining. I request you all to be on mute. If you have to
Hey, hi,
ask the
Ankur.
questions, then only you have to unmute.
Okay, Ankur, can I start, or do you have any certain instructions or something like that to cover?
No, I think all good. Thank you, Harkirat, for making your time available. Guys, it's very important session and it's getting the time of the, SME is always, from their projects very difficult. So I request everyone to utilize this series, and it's a series of 5 sessions. So please be ensure that you are joining the session on time, utilizing this entire time as well. Post this session, though, Harkirat will share the what are the prerequisite of the softwares. Otherwise, I'll drop a mail to all the people who attended the day one session so that next day you have the prerequisite software in your machines. Though I'm sure Docker and everything you must have. Otherwise, some more things will be required for the Kubernetes. And please mute yourself during the session. Thank you, Harkirat.
Yeah, thank you, Ankur. Thank you. All right. So again, good morning, good afternoon once again. So okay, the idea here is we're going to cover the basics of Kubernetes. So we are going to cover enough so that you guys can get started with the hands-on sessions. It's very difficult to cover the entire Kubernetes in 1 week. Even it's very difficult to cover in 1 month also. But we are going to just go through the basics and get started enough so that you guys can even deploy your own application, do hands-on, etc. So we'll start with it. There's a notable difference between Docker and Kubernetes. Uh, Kubernetes is doing the same thing which Docker is doing, basically containerization of all the applications, and then finally deploying them as microservices rather than having one monolithic application. But there is advantage over Kubernetes, which Docker doesn't have. And there are a lot of advantages over that, which we're going to cover in the next slides. So the agenda for these 5 days will be to cover these main topics. So just I'll give you a high level overview on each topic which we're going to cover. The first one, as you can see, will be the purpose of Kubernetes, why everyone is shifting from Docker to Kubernetes, or if the people who are just deploying their applications as a normal stack, they are moving from that phase to the Docker part. Then the next thing is what kind of features does Kubernetes offer? Why do we need to switch from Docker to Kubernetes? The third will be the architecture. Architecture is very important. I'll try to spend at least 15-20 minutes on that so that we are aware about how the components are interacting with each other. And finally, then we'll be moving to the objects in Kubernetes. In Kubernetes, you can have various objects are there, but we'll start from the basic, which is the pods. Pods is just basically an abstraction over the containers. In Docker, you have containers, and pods is a layer which is abstraction over that container. Then we are going to go to the YAML part. YAML is basically yet another markup language. We're going to understand that syntax. If you guys are familiar with that, we are going to move on. But if I was hoping that we can spend 5-10 minutes on that so that every resource which we deploy in Kubernetes will have this YAML language. So I wanted to spend some time on that. The next thing is the config maps and secrets. Basically, these are used to feed in environment variables to the microservices, which we're going to cover in the next sessions. Then the next part is the most important one, types of services. So every component wants to interact with each other. So the smart way of doing is by creating services. It's important part of the network part in Kubernetes, which we're going to cover. Finally, we'll have the actual application, which we're going to deploy via a YAML file called deployment. And finally, the most important part is the ingress, how we are going to expose that application to the outside world. So basically, by going through all these steps, all these points, we're going to have enough on our plate so that we can get started with the demo also. I have one demo planned also at the end of this session. So we're going to cover that as well, in which we're going to deploy one live application, and you can see that on your browser also. Okay. So this is the basic part. Then next comes the advanced topic. These won't be covered in this 5-day series because there are a lot of stuff to cover. So if things go well, we can plan out other series also, and these will be the topics which will be covered. We have volumes, we have HPA. HPA is horizontal pod auto scaling. So which means that depending upon the load on the application, your pods or the containers will scale immediately. They will do, you can have a horizontal scale, you can have a vertical scale also. And this part we'll cover in the further topics. The next thing is a kube config file. Kube config file is your heart of the cluster basically. It has all the certificates, etc., which is required. As of now, you can ignore these things because these are very high level. So the idea is to cover these things in the further topics. Something about me. So I did my BTech in mechanical engineering. I have total of 5 years and 4 months of experience, and I recently joined Infogain. I'm currently working in Infogain in the Seagate account. So I'm currently working on AKS over here, as you can see below. And in my previous company, I was working in OpenShift. OpenShift is basically a flavor of Kubernetes. I was responsible for deploying clusters in AWS, Azure, and GCP. Then you can see I have practiced on Minikube and online lab environment from October 19th. So also I'm certified in Kubernetes. I have a CKA certification with me, and in other tools I know Jenkins, Azure, AWS, Bitbucket, shell scripting, Ansible, Argo CD. Argo CD is, you can say, if you guys are familiar with Jenkins, Argo CD is used for deploying mainly Kubernetes application. That's the basic part. Okay. So without any further ado, let's start. Okay. So the first question comes up in our mind is, if we have Docker running, we have containerized our applications, everything is working fine, we have various microservices, why the need of Kubernetes? So as a layman, I can say the first thing is, if I want to make sure that, suppose I want to have high availability, I want to have zero downtime, I want to make sure that my applications scale in and out, I want to have more control on how my containers are deployed, how the containers are interacting with each other, then that's where Kubernetes comes into picture. Your Docker is basically a simple engine in which things are working in a pretty normal pace. But what Kubernetes does is it brings you a lot of leverage, in which you can deploy the containers in whichever way you want, on whichever nodes you want, all that part. So the basic of purpose of Kubernetes is to host your applications in the form of containers in an automated fashion. This term is very much important, in an automated fashion. Basically, it brings in a lot of automation into picture. So we're going to cover that in the next part, so that you can easily deploy as many instances of your application. In case of Docker, you can have only one container for your application. If you want to deploy another container, you need to have it in a different name. But in case of Kubernetes, you can deploy as many instances of your application. So it can serve as much load as possible, as required, and easily enable communication between different services within your application. This is done by creating various services. So this is basically the main purpose of Kubernetes. It brings in a lot of flexibility with your components. Okay, moving on. So these are the important things that Kubernetes offer, which Docker doesn't. The first thing is automated rollouts and rollbacks. Suppose there's a requirement in your project that you need to upgrade your applications to a different version. So you want to move from version 1.2 to 1.3, and you have deployed 1.3 on your application, but somehow something went wrong and your application is not working as expected. So with a simple one command, you can roll back to your entire previous state, which is a very flexible situation. But in case of Docker, you need to go inside, change things, and then finally roll it back. The next thing is service discovery and load balancing. So automatically, whenever if you have your applications, which is a front end application, which is has around say 7-8 containers. Those are actually 7-8 pods, but as of your understanding, I can say 7-8 containers. And the traffic comes in from the front end, and automatically it will be load balanced to all the backend pods. So it won't like the pod one will have faced most of the traffic. Accordingly, it acts as a load balancer, and automatically it diverges the traffic to the various pods. The next thing is the self-healing part. So if
I have
suppose your container, yeah,
Harikant,
any doubt?
interruption. Can you repeat the service discovery and load balancing part?
Yeah, okay, sure. Okay. Mm, okay, you can note down this point. We'll come back to this point because when we'll cover this thing, na, Kubernetes architecture, it will cover that point. Okay. As of now, you can note
Okay.
it down. I'll come to that part. Yeah. Next thing is your self-healing part. So there's a component called Kube API server. It automatically checks for the state of the applications, and if suppose one of the applications goes down, it passes the traffic to the other application. So that's how your self-healing part comes into picture, and automatically your pods will retry everything. It will try to come back up. That is also one feature of your self-healing. Everything will be covered in the demo part. So
What
that
is
will
the
be
meaning of the pods here?
okay. Nice question. So let me jump further. Okay. So, are you guys familiar with the concept called containers? Correct.
Yeah.
In Docker we have containers. Now in Kubernetes we don't have containers. We have pods. Pods is basically an abstraction over that container. So in a single pod you can have around 7 containers deployed. Okay. But
Okay.
generally it's in Kubernetes is one to one is there, means in one pod you'll have only one container.
Okay.
The reason for having pods is it gives you more leverage on how you can deploy the things, and which we're eventually going to cover in this part. Okay.
Okay.
As of now, let's move to the architecture first. We're going to cover this in the further slides. Yeah. So the next thing is horizontal scaling. As I told you that whenever there is some load, your pods or your containers. Uh, as of now, you guys can think whenever I'm saying pods, it refers to containers. Okay. As of now, you can think it like that. So whenever some load is applied on the application, your containers will scale automatically. This is called horizontal scaling. This will be covered in the future part. The next thing is secret and configuration management. In case of Docker, if you want to pass in your environment variables, you can do it via the configuration files inside the environment variable. But in case of Kubernetes, it gives you more leverage in which you can have separate secret and config file YAML files and feed in those environment variables to your respective containers. Okay, don't worry about it. As of now, if you guys don't understand it, slowly things will get covered. Okay, as we move along to the other parts. Okay, so the next thing is the most important part we're going to cover is the Kubernetes architecture. Okay, so think of it like this. In a Kubernetes world, you have various nodes. Nodes can be your virtual machine. They can be on any cloud environment, they can be on-prem also. Now we'll have two types of nodes. One is the master nodes and one is the worker nodes. Your worker nodes will actually be having all the applications which you are going to create. So if you're working on a project, there will be a development team who will be creating your applications, who will be creating the images, and you will be deploying those applications on the worker nodes, or you can say the virtual machines basically if you're thinking about the cloud world. Now in these worker machines, you'll be having those pods or the containers which will be actually deploying your application over here. Okay. Now coming to the master part. This is the new part which will come into Kubernetes. So in this master, you have various components, and these components have nothing to do with your actual application. But these components are very much necessary in order to facilitate all the tasks which are going in the Kubernetes world. So one by one, we'll try to cover each and every part, and then we're going to move ahead. So the first thing is your Kube API server. So whatever command that you pass into your Kubernetes cluster, whatever interaction it happens, everything goes via this Kube API server. It exposes an API. So if you guys might be aware what an API is. So whenever if you want to interact with any of the component in the outside world, you want to interact with the Mongo cluster, MongoDB, or any application, everything happens. All the communication happens via an API. So this is the component which exposes one API, which is responsible for communication between your worker nodes, your master nodes, your containers, your services, everything. So this is the most important component. And also, let me just show you one thing. I have in my system, I have Minikube running. So I'll be just dropping an email after this session that what all you need to install. If I do Minikube status, okay, sorry. If I do Minikube status, it shows you the kubelet is running, the Kube API server is running. If the Kube API server goes down, everything goes down. Okay. Basically, this is it exposes one API which is responsible for all the communication which is inside and outside the cluster. Okay. Going back. Yeah. So the first component is done. Kube API server, it exposes one API. The next component is the etcd server. So this is your, you can say, a database inside the cluster. It's your key value store. This will have, if you are fetching any information from the cluster, all the information is stored inside this cluster, etcd cluster. Okay. So the next component is your kube scheduler. Now, so whenever we are going to place any pod or a container, so if I say I want my pod A to be placed on this machine,
Sorry to
worker machine.
interrupt, Harikant. Can you repeat
Yeah.
etcd cluster, please? Once again.
Okay, sure. Yeah, sure. So etcd is basically your key value store. You can say it's a database inside your Kubernetes cluster. So whatever information which you want from the cluster, if suppose you want to fetch how many pods are there, kubectl, there's a command for that, kubectl get pods. So if you do Docker, I have Docker installed on my machine. So if you do Docker PS, it lists you the containers, right? If you do Docker
Yeah,
PS
yeah,
hyphen A, it lists you the containers which are in the stop state. But
yeah.
coming to the Kubernetes, if you do keep CTL with pods, this is the command to list down the pods or the containers. As of now, you can say that this
So this
operation
is
will be performed.
performed
Yeah.
by the
So
etcd container, etcd cluster.
the information is fetched from the etcd cluster. Okay.
Yeah, okay. Okay, great.
Yeah. So etcd will have every information inside it. So okay, let's not jump to this. This etcd will have every information which you are expecting from the cluster. And if you are deploying something to your Kubernetes cluster, that part will also get stored inside the etcd. Okay, got it? Okay.
Okay,
Now,
Harikant.
yeah. Okay. Thank you. The next component is kube scheduler. So as I told you that your applications will be deployed on the on the worker nodes, but that's not true always. If you want, you can have your application deployed on the master node as well. So your application, your container will be deployed like over here or over here wherever possible. But the idea is you should never deploy anything on your master node. Master node is usually just done for your management purposes. Okay. Now, so these all things, etcd server, kube API server, kube scheduler, these are also deployed as pods only, as containers in the cluster. So if I show you kubectl get pods hyphen n kube system, you can ignore this hyphen n cube system as of now. I'll tell you what this is later on. But here you can see etcd, you can see your kube API server, your kube controller manager, all those things. etcd, kube API server, kube scheduler, and kube controller manager. Kube scheduler and kube controller manager. And you see this ready status. This means these are deployed as containers, as pods basically. Okay. So now kube scheduler. this components, okay, let me open the slideshow again. Yeah. So suppose in your project there is a specific requirement that you want pod A, your pod A is serving a web application, your pod B is serving a database. You want pod A to be placed on node A and you want pod B to be placed on node B. So how can that be done? And which is the component that facilitates those things? It is done by this kube scheduler. So kube scheduler is basically responsible for selecting which components, which pod will be placed on which node. You can make a note over here. Kube scheduler does not actually deploy the pods. It is just responsible for selecting which component will go on which node. Okay, that's the function of kube scheduler. The next thing is your kube controller manager.
So
And
how it
as you
would
can,
know? So how it would
Mhm.
know that in a Node 1 you have to run your web application and in Node 2 you have to run a database.
Yeah, so there will be requirement from your project that you want your node pod A to run your web application and pod B to run your database application. And there's a requirement that you want pod A to be placed on node 1 because you can say that node 1 has more CPU requirements. Your application requires that. So what you can do is in the pod manifest file, in the YAML file, you'll
Hmm.
create one kind of affinity rules and you'll apply those rules, and on the basis of those rules kube scheduler will see, okay, these rules are there, so these pod will should be placed on node A, like that. Okay, we'll cover
Okay.
these things. These are actually advanced topics. We'll cover these things when we go to the YAML part. This is the YAML of the pod syntax. This is the basic syntax. When we'll cover this part, we'll cover all those things also.
Okay.
Okay. Yeah, you guys can note down your questions side by side, whichever doubts you have. And slowly, when we cover the entire PPT, I'll try to make sure I cover all the doubts. Okay. Yeah. So this is the responsibility for your kube scheduler. Okay. Now the next component is your kube controller manager. As you can see, there are 3-4 boxes placed over here like this because kube controller manager is not a single component. It's basically a combination of 10-12 components all bundled up together. Each component has a separate task. For example, there is a component called pod replication controller. There's a component called node replication controller. All these components have specific tasks, and all those tasks combined, they form this kube controller manager. There is one component called node controller manager. And suppose if in your this Kubernetes cluster, you have a requirement there is one master node and there is one worker node. And since I told you that these are basically virtual machines, and suppose some disaster happens and your worker machine is, suppose this master node is in West US region, and suppose this is in the North EU region. I'm just taking a hypothetical example. And suppose this North EU thing goes down, your virtual machine goes down. So your node replication controller will make sure, okay, it will see that that node has gone down, so it will automatically spin up another node, okay, and it will join that node to our cluster. So this is how the self-healing part works. That is one example. The next thing is
So
pod.
in a virtual machine, we have to install your Kubernetes and Docker.
No, not necessarily. So what you do is there are various ways of creating a cluster. So if you go here, as I told you, currently I'm working on AKS. Previously, I
Yeah.
worked on OpenShift. Okay.
Yeah.
In case of OpenShift, what we used to do was we used to. I'll just give example of OpenShift and then I'll give you example of AKS.
Okay. Okay.
Both are different things. So in case of OpenShift is basically a wrapper which is built on top of Kubernetes. So it gives you additional components to interact with the cluster. So if suppose I created my cluster in OpenShift in Azure environment, it spins
Mm,
up 3 master nodes and 3 worker nodes. Okay.
mm, mm.
And suppose, and you don't need to explicitly install anything on that node. Okay. So the only thing is in from the node which you are interacting with the cluster, in that node you need to install kubectl. That's it. For example, let me
Okay.
give you one example in my current setup. Currently we are using AKS, okay, Azure Kubernetes Services. So if I do, currently I'm on my local system, okay. As you can see, this is my local system. So Kirat Singh @ SIT. This is my local system. So
Okay.
if I do this kubectl version. One second. Okay, so I have this kubectl installed, and I don't have any cluster running. I have it in Minikube, but you can ignore the Minikube part. And suppose I want to, let me show you that also. So this is my Microsoft Azure, and if you go to this Kubernetes services, so you have these clusters running, okay, AKS clusters. But what AKS does is that it won't, Azure is going to take full responsibility of these components. Once again. So these master node components will be taken care of by Azure. You don't need to worry about all these components. Okay, they're going to be only, you're going to only focus on the worker nodes. So if you go to this thing, right, this is the cluster. Okay, this is a cluster at the back end. This is one node. Okay.
Cluster is basically, you can say that it's an application, right?
No, it's not an application. Cluster, you can say, is basically, how should I put it? Okay, cluster is basically a combination of the stuff which is required to run the cluster, and it sums up your application also. Okay, and if suppose you remove your application from that cluster, it will still remain a cluster.
Okay.
Okay, so if you do this, and if I want to connect to this cluster, AKS cluster, I need to go to this connect part, and I need to fetch this connection string from here, this one. Okay, I need to just fetch this connection string, and I need to pass in over the command line, and I will be able to make a connection. But I won't be able to make it from my system. Okay, because we need to go inside a particular VM, and then from that VM, we're going to go to that cluster. Okay.
Can you repeat it? Just can you repeat it for after the copying this command?
Okay. So basically, what this command is going to do is, let me copy this command for you. Okay. So this command is AZ is for your Azure command line command. It's going to get the credentials from this resource group, and then the name of the cluster is this one. Okay, fleet management app. If you run this command, okay, let me run it for you. Okay, now I'm inside one VM. As you can see, previously I was inside my local machine. Harkira Singh iterate this thing. Now I'm inside my one virtual machine. Okay, from this virtual machine, I'll be able to connect to the cluster. Okay, this is for security purposes, obviously. And if I run this, let me run a different cluster. This one I'll run it. I want to show you the message which will come when you do this. Okay, now you can ignore this thing. This is just a connection string to connect to the cluster. Different flavors will have different connection strings. In AKS, you're going to connect with this. In AWS, you're going to have a different connection string. In OpenShift, you're going to have a different connection string. Okay, you can ignore this connection string, but the idea to focus is to use this one. See, it says merge this thing. You can ignore this part as current context. This is important. Current context in kubeconfig file. So basically what it does is it creates a connection with that cluster via this kubeconfig file. Okay? So that's why I told you that kubeconfig file is the heart of the cluster. In my
So
starting
you have
of
to first you have to go through your VM, and after that VM, with the help
that,
of the command, you can go
that's the
through
project setup. That's a project setup. Going to a VM. It can't be necessary to. It's just for our project that we want to go inside a VM and then connect to that cluster. If you don't apply that rule, you can do it from your machine also, local machine. But the idea is you need to have that connection string with you, and that connection string is going to basically merge the kubeconfig file, and with the help of that kubeconfig file, you're going to have the cluster connection. So here you can see in the advanced topic, there's a thing called kubeconfig file.
Cube
Okay,
config file.
with this kubeconfig file, you are able to make the connection to the cluster. So you can say this kubeconfig file has the required credentials with you, and those credentials, when you pass in those credentials, it will make a connection with the cluster. Okay, does that answer your question?
Yeah, Harikant, yeah, absolutely.
Okay,
Okay.
okay, cool, cool. Okay, so we covered Kube API server. Kube API server exposes one API. We cover etcd cluster. This is the key value store. We cover kube scheduler. This is the component which decides that which pod or slash container, which container will be placed on which node, node 1, node 2, node 3, etc. And finally, we have this kube controller manager component, which is responsible for ensuring that the number of pods, number of nodes are in the required state. They should be healthy. It just sends this component via the Kube API server sends health checks and sees that all the nodes are up and running and all the pods are up and running or not. Okay. Moving along, the next thing is also one more important thing. Since we are dealing with containers everywhere, we want everything to be container compatible. So we need to have either Docker or its equivalent. It can be Rocket also installed on all the machines. Okay. Generally, what happens is Docker and Kubernetes go hand in hand very well. So wherever in 99% of the cases, the person who are using the Kubernetes will be using Docker at the backend only. But there are few exceptions in which people using Kubernetes will be using Rocket, not Docker. Okay. Now coming to the worker nodes, you have two components running. One is the kubelet and the second is the kube proxy. Now the first thing is, what does kubelet do? I told you that kube scheduler is the component which decides which component will be placed on which pod will be placed on which node. But in case of kubelet, this is the component which actually deploys your pod on the node. So it actually deploys your container. Okay, you can think of it as the captain of the virtual machine. So whenever you need to install any pod, any container, this will be done via the kubelet. Okay. The next thing is your kube proxy component. So kube proxy, what does this kube proxy component do? As I told you that there are pods and there are services in the start. So there are pods and then there are services. What the services do is services help in communication with the various pods. Okay. The purpose of this queue proxy is to look for what new services are getting created in the cluster. Okay. As of now, you can just think of it this way that queue proxy, the purpose is to look for what kind of services are getting created in the cluster. And whenever these services are getting created, it needs to create appropriate rules on the nodes so that they can forward traffic to the backend pods. I know these are very heavy words. I understand if you guys don't get it, but soon when we go through the demo part, I'll make sure you get understand each and everything. Okay. So as of now, you can just make a note that kube proxy is used for the function of kube proxy is to look for various services which are getting created in the cluster. Okay. As of now, that's it. So just to summarize, in Kubernetes, you have two kinds of nodes. One is the master nodes and one is the worker nodes. These nodes can be your virtual machines or if they're running on the cloud. And your master node will have all the components which are actually required to facilitate all the processes. And your worker nodes will have your applications which are being deployed on those nodes. Coming to the master node, you have four major components: Kube API server, etcd cluster, Kube scheduler, Kube controller manager. Your Kube API server is the component which exposes one API, and all the communication, everything which happens, it goes via this API server only. The next thing is your etcd cluster. It's basically a key value store which is responsible for storing all the information in the cluster. The next thing is your kube scheduler. It's the component which decides which pod slash container will be placed on which node. Fourthly, we have this kube controller manager. It's responsible for ensuring it has a various set of components which are working in unison to achieve a required state. It has various like node replication controller is there, pod replication controller is there. All those offices have a particular task, and all the tasks combined, you can say, form this kube controller manager component. Coming to the worker nodes, you have your kubelet. This is responsible for actually deploying your application or deploying the pod on the node. Then you have your kube proxy. Kube proxy is basically the component which looks out for all the new services which are getting created in the cluster. Okay. Any doubt on the architecture? Over the high level view, obviously. I don't expect you guys to know everything in a split second. So on a high level view, do you guys have any doubt? Okay. So moving along, whatever I said, I have written over here few points, so we can go through this. So the worker nodes, I told you, they host the pods that are the components of the application workload. So you deploy all your application on the worker nodes. You don't deploy on the master nodes. Okay. So the worker nodes, they host the pods that are the components of the application workload. The next thing is the control plane. The control plane is basically this one. Master node is referred to as the control plane. So manages the worker nodes and the pods in the cluster. I told you that this kube controller manager this is responsible for managing the worker nodes, the pods, etc. Everything. So basically, your control plane is all these four things: etcd cluster, kube API server, kube controller manager, and kube scheduler. Okay. Now the next thing is in production environments. This is important. The control plane usually runs across multiple computers, and a cluster usually runs multiple nodes, providing fault tolerance and high availability. What this means is that in this picture, you can see there is only one master node and two worker nodes. But in a production setup, there will be usually three master nodes. Okay. And during at those three master nodes, only one of them will be active at one time. Okay. You can have all three of them are also active. It depends on the project that you're working on and the kind of architecture that the project has. So the idea is to make sure you guys understand the fundamentals. And whenever you are working on a project, every project will have a different requirements. But the middle part, or you can say the important component, will be Kubernetes, and that's what we're going to cover today, or in these 5 days. The next thing is, so we have few points lined up with this Kube API server. The API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end of Kubernetes control plane. Every operation goes from this Kube API server only. Okay. So every operation performed goes through the Kube API server. Example, the interaction between kubectl utility and the cluster is facilitated by the Kube API server. So one question comes here, what is this kubectl? So if you do this, let me go back. Yeah. So you guys know Docker pretty well. So whenever you want to do any operation, you do Docker ps, do Docker ls. I'm sorry, Docker images ls. Okay, if you want to fetch the images. So what is this Docker? Basically, you are interacting with this Docker via this utility only. And what is this kubectl? This kubectl is also a utility. Okay. This and in case of OpenShift we have a utility called OC. So OC get pods will be there in case of OpenShift. Okay, it won't say OC not found because it's not installed in my system.
OC
And this
is also type of Kubernetes, na?
yes, you can say OC is for OpenShift. OpenShift is basically a wrapper which is built on top of Kubernetes. At the backend, it's using Kubernetes only, but what it does is OpenShift gives you a lot of leverage. It gives you a UI to see the pods. It gives you a proper. There is one more thing that if you want to see the logs, etc., you need to deploy a lot of stuff in your native vanilla Kubernetes cluster. But in case of OpenShift, all those things are automatically installed. Okay.
Okay.
So basically, you have various flavors of Kubernetes in the market, right? It all depends it all depends on the on your project requirements which you want to use. Okay. For my practicing purposes, I'm using Minikube. So I just showed you. Okay. So I told you that you have two. 1 second. I told you there's one master node and there is one worker node, right? But in case of, let me show you a difference, like how the flavors of Kubernetes vary. So I'm inside this. This is my office thing. So if you do kubectl get nodes over here, you can see there are two nodes, and these are worker nodes, by the way. Okay. in this this is my office stuff, okay. But if you do to my local thing, if I do this, this is running minikube, okay. If I do kubectl get nodes, you will have only one node over here. This, see, this is only one node, and this runs both your master node and worker node, same thing only. You can you deploy your worker applications also on the same node, because this is just for practice purposes. That's why minikube is basically a way of doing practice. It spins up one virtual box at the backend, and I'll list down the requirements which I want from you guys to install. So if you do this virtual box, so minikube at the backend runs a virtual box, which is one node machine. Okay, it has two CPU processor and this all those things. It's running a Linux at the backend, and this has only one node. Okay, so there are various flavors of Kubernetes available. It all depends on the project that you're working on and the requirement that they are using. Okay, but the core components always remains the same. So let me move ahead now. Okay, so API server. Now Kube server, this is an important point now. Kube API server is the only component that talks with the etcd server. Okay, so this question can be part of your interviews also. That etcd is the only component that talks with the Kube API server. No other components, kubelet, kubeproxy, no component talks directly with the etcd server. Okay, so if any information is fetched from etcd server, it goes via the Kube API server. Okay. Next thing is, what's the etcd server? It's consistent and highly available key value store used as Kubernetes backing store for all the cluster data. Every information is stored in the etcd server. If your Kubernetes cluster uses etcd as its backing store, make sure you have a backup plan for those data. Okay. The next thing is your kube scheduler. Kube scheduler is the control plane component that watches for newly created pods with no assigned node and selects a node for them. This point is very important. It selects a node for them to run on. It doesn't actually deploy the pods. It just selects which pod will be placed on which node. Okay. Then coming to your question, you wanted this. Factors taken into account for scheduling decisions include individual and collective resource requirements, hardware policy constraints, affinity and anti-affinity specifications, data locality, interload interference, and deadlines. Okay, so for example, I'm giving you one example that suppose my pod A, it wants has to be placed on node 1. Okay, the reason for is that pod A consumes high CPU. Okay, pod A serving your web application is consuming high CPU, and let's say it consumes around 3 vCPUs, and the requirements on the node B is that node B only has 2 vCPUs left. So obviously it should be placed on node 1, right? So that is one requirement. So kube scheduler, while scheduling the pod, it will see, okay, this machine doesn't have the appropriate CPU requirements, so it should be placed on this machine. Okay, all these functions are taken care of by kube scheduler. That is one example, and the other part can be all these things: collective resource requirements, hardware rules, affinity and node affinity specifications. This is a bit advanced topic. We have taints and tolerations, affinity and node affinity rules, etc. All these things will be covered in the advanced topics. Okay, does it answer your question?
Yes, Harikant, yes, absolutely.
Sure, thanks. Okay,
So
moving
if we
along.
want just, for example, if we have an application, a front-end application, and
Yeah.
suppose if we want to create a data in the back
Mm-hmm.
end, so it's, you said that the Cube API server is responsible to expose that particular API. So here is working one node having an front-end application, and when we suppose we having a button that creates the to put an entry into a database or record into database. So
Mm-hmm.
in this in this part we have to schedule, we have to in a working node 1, and we are just going into the working node 2. So what is responsible for this?
Okay. Uh, let me try to answer this question. So this pod A, this is suppose serving the front end application. Okay, that's your question.
Yeah.
And this pod will be serving your database. Correct. So what the thing is, it depends on the requirement that whether you want to place this pod on node A or node B.
Mm.
It's a
Mm.
possibility that you can place both the pods on node A. Okay,
Yeah.
let's for example we can take we have deployed all the pods on node A.
Mm.
Okay, okay. So you can think of it that the pod is also placed on node A and pod B is
Yeah.
also
Yeah. Yeah. Okay.
placed on node A. Okay. Now what
Okay.
happens is if you want to enable communication between this front end and this database, there's a
Mm.
service comes into picture. So you have this service over here. You can call it SPC1. Okay. So
Mm.
this service will be the component which will be in between these two components. So from
Mm.
pod A, traffic will come, it will go to this service, and it will see that service is going to move the traffic back to the pod B. Okay,
Mm.
this is how the communication will take place. And both these pods will be placed on the node 1, or even if suppose one pod is placed on node A and the other pod is placed on node B, still there is no issue in that. Every component on any node can talk to every other component on any other node as long as they're part of the same cluster.
Okay.
Okay, does it answer your question?
Yeah, yeah, okay, okay. And one question also, one question that, for example, if we having a Spring Boot application, so in a Spring Boot application, we generally use having a model, and model is just a model is activating part which is used to go on from service to service layer to the front end dispatcher servlet, and also so in this case, we if we deploying our Spring Boot application, and in the Spring Boot application we have just an suppose that we have an front end application in a pod A and a back end application in a database application in a pod B. So we use the service app, the service here. Without
Mhm.
using a service, we can't no, we can't just moving to the pod B.
No,
Matlab
we can
I
move
just
it.
want to
We
know
can
that
move it. Yeah, yeah. Okay.
I
So
just
actually, that was
uh,
supposed to be covered in the next topic, but I'll cover you. In Kubernetes, by default, any pod can reach to every other pod. Okay. Let
okay,
me
okay,
show you this. So I have a demo practice application with me. So I'm just going to apply all the components. You can ignore this thing. Okay. Don't worry about it. So
okay.
if I do okay, so if my do kubectl get pods, these are two pods running. Okay,
Hmm.
this one is the your front end application. This is your back end application. Okay,
Okay.
by default, this pod can reach this pod. How they can do it via the IP address. So this pod has this IP. Okay,
Hmm. Hmm.
and this pod has this IP.
Hmm.
Okay, so by default, this pod can interact with this pod via this IP. Okay,
Okay.
now suppose if I delete this pod.
Hmm.
Okay, because in the production setup it's very common, right? One pod can be
Hmm.
deleted.
Hmm.
So if I delete this pod, so it will automatically spin up another pod. I'll tell you why. This is part of why Kubernetes is highly available. So if it had one pod, I deleted this pod, it takes some time to delete it, it will automatically spin up another pod, but you'll see that the IP address will be different. Okay, let me
Okay.
show you
Okay.
that.
Okay. Okay.
Let me
It
show
is
you one second.
deleted, right? And the pod is deleted, and the pod is deleted, but it spin up into the another pod.
Yes,
That application will
yeah,
be installed on another pod. You say that.
yes, correct.
Okay.
So
Okay. Your
uh,
application never goes down.
yes, that's why it's highly available. So if you do again kubectl get pods -o wide, you'll see another pod is spin up, and this is just
Having
spin
a
up right now.
different
Okay,
IP address.
and it
Yeah.
has a different IP address. Okay,
Okay.
that's why you can't use pod to pod communication because in a production setup, on a daily basis, many pods are going down and automatically new pods are coming up. Okay, new pods are coming
Okay.
up, so that's why you can't use pod to pod IP communication, because you need to then how does the communication works, right? So you need to
Okay.
have,
So
in
with
case
the
of,
help of the services, you can just go
yes,
through
yes, yes.
another pod.
If
Okay.
suppose you don't have services with you, you'll just have one set of pods running and another set of pods running. So you
Yeah.
need to have IP table rules created in the Linux environment. So you need to have this IP table rules created on this, that this thing will forward the traffic to this pod. Okay, this IP address.
Okay.
But suppose when this IP address goes down, you need to again change the IP table rules. So that's a very
Yeah.
hectic part, right? So
Okay.
for
Okay.
doing that, what you do is you create services. So you create
Okay.
services, you do kubectl, get SVC. So ignore this service. This is created by Kubernetes automatically. These are the services which is created by me. Okay. So these
Okay.
services, if
Okay.
you do kubectl get service hyphen o wide, so these services, you can see these are the cluster IP. I'll tell you what this cluster IP is, but these services have these IPs. Okay,
Okay.
and these
But the
services,
service, in
uh-huh.
the services, we have to written a code, or it is, given
Yeah,
by the
yeah.
Kubernetes.
No, no. We are going to create it.
Actually,
Everything
we
we are
are
going
going
to create it.
in which
All
language
the
we are going to create?
YAML,
YAML.
YAML
Okay.
language.
Okay.
Yes, yes.
Okay. Great.
Yeah,
Okay. Okay.
yeah, yeah.
Okay. Fine.
So that's how everything will be sorted out. Don't worry, yeah. But thanks for asking the questions. Okay.
Okay.
So the thing is, then you have the services in the middle, and you can, your pod can get deleted. New pod should come up. It's then the responsibility of the service to create a proper rules on it to forward the traffic. Okay. Service is the one which is going to create. Now suppose this pod gets deleted, a new pods come into picture. Okay, since the system is highly available, so it will create another pod automatically. So now this pod B comes up. This is a different IP address. Now it's a responsibility of the service to create appropriate rules so that the traffic goes back to this pod. Okay, service does this internally. And now next question should come in your mind, that what if the service gets deleted, then what happens? For that you have this kube APS, this thing, kube proxy. Sorry, where is it? So if suppose your service gets deleted, then this is your queue proxy service. You need to create a service again. And then this queue proxy thing, this is the component which is responsible for checking which services are getting created and destroyed. Then this is the component which creates appropriate rules on the nodes. And this is done via IP table rules. Okay. And this, you don't need to worry about it. This automatically, this component will do those things. Okay.
There is one more
Did
question.
you?
Uh,
Uh-huh.
Please, whatever the required document we need, required software we need, for example, Docker
Mhm.
and Kubernetes and VM, you just note it down in a mail so that we can install them by ISSQL.
Yeah. I'll do that for sure.
Okay,
I already
okay,
sent this mail to Ankur today. You're going to get this email after this session.
okay,
Okay.
okay.
So let's quickly cover the other things. I wanted to cover these things today. Yeah. So just will go quickly read out the other things. Okay. The next thing is your Cube Controller Manager. So as I told you, Cube plain component that runs controller processes. Logically, each controller is a separate process, but to reduce complexity, they are all combined into a single binary and run it as a single process. I told you, right? There are many components in Cube Controller Manager, but you combine all those components and you call it as Cube Controller Manager. Okay, that's the same thing it's saying. Now, some of these types of controllers are, node controller is one component responsible for noticing and responsible responding when nodes go down. Then you have job controller, watches for job objects, and then you have endpoint controller, populates the endpoint, like join services. And for this endpoints is responsible. Endpoints is a component which is responsible for joining the services and the pods. So if you do kubectl get endpoints, hyphen a is a flag which is responsible for getting all the endpoints. Okay, but I don't want that. I just want to see the endpoints in this namespace. So you'll see these IPs. Okay, this is the IP followed by the port number. As of now, you can ignore the port number. But what is this IP? This IP is basically your pod IP. This one. Okay, and your web app service is serving your web application, and this is that IP. Okay, if you delete this pod, it will spin up on a different endpoint because the pod will get a different IP, so endpoint will get changed. Okay, but you see the age is the constant over here. Okay, uh, we'll anyway we'll cover these topics in the demo sessions. Let's just cover this theory part quickly. We are anyway going out of time. So similarly, job controller is there, endpoint controller is there, service account and token controllers is also there. What is a service account? What is it? What is our namespace? We'll cover in the further sections. Then we have this kubelet and kubeproxy. Kubelet is again an agent that runs on each node in the cluster. It makes sure the containers are running in a pod. Okay. The next thing is kubelet takes a set of pod specs. Pod specs means your YAML file, okay, which we are going to write, which we will write it together, that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. Okay, so basically your kubelet is responsible for deploying your application. And how do you deploy your application? You deploy it by providing a YAML file, and kubelet will take into consideration those YAML file, and it will deploy that pod. Okay, the next thing is your kubeproxy. Kubeproxy is a network proxy that runs on each node in the cluster, implementing part of Kubernetes services service concept. Kubeproxy maintains a network rule on the nodes, IP table rules. This I was talking about. These network rules allow network communication to your pods from network sessions inside or outside your cluster. Okay, so all these things will be covered. You can read it in your free time. So the next thing is your container runtime. Container runtime is basically your Docker. It can be Docker, it can be container D, it can be cryo. It depends on the project which you're using. Okay, their requirement. And then we have few add-ons. Add-ons are like daemon set deployment. Deployment, which we are going to cover in these 5 days of series. Daemon set we're not going to cover. It's a bit of advanced topic. So the idea is to get you started with the Kubernetes, and this is something a bit which it comes in the advanced lecture. We'll cover it in the next sessions maybe. So maybe we can stop here because these topics will require some time. Uh, so okay, so we're stopping here. Tomorrow we'll try to cover these things, other important components, and then the next parts. Okay. Uh, any last doubts, anyone? So that's the basic overview. I wanted to get you guys started. So I know there will be a lot of doubts. You won't be getting it completely. That's completely understandable. But during this course of 5 days, you'll get to learn a lot of stuff, and make sure you're noting down all your doubts. And I'll try to resolve that. Even if on the last day maybe we can have a 2-hour session also, 1 hour extra session for your doubts only, and we'll try to cover each and everything.
Okay,
Any last
so
thing?
my
Yeah.
question is that the Docker is in a containerization and Docker having a Docker engine, you say. So the Kubernetes and Docker are the different things. Or you can say that we can run the Kubernetes alone with the Docker. It is a dependency, or you have to install the Docker for work in
Yes.
Kubernetes.
Yes.
Okay.
You need at least, as I told you in the architecture, right? You need everything to be container compatible. So either
Okay.
you have Docker with you. 1 second. Sorry. Yeah, either you have Docker with you, or you can have Rocket or Cryo also. Rocket and Cryo
Okay.
are also Docker, are containerization engines also. Only if you see
Okay.
now
Okay.
this point. So Kubernetes supports several container runtimes. It can be Docker, it can be Containerd, it can be Cryo. But
Okay.
generally, 99% of the people use Docker with Kubernetes. But it can be Containerd or Cryo also.
Okay. Can you share this
Okay.
PPT also?
Yeah, I'll do that for sure. Actually,
Okay.
it's PPT is in still development, so a few things are not there. Example,
Okay.
after this
Okay.
advanced topics, but still I can share whatever version I have with you. Okay,
Okay.
no issues in that. Okay, sounds good. I think we can drop here. I need to work other things. Thank you guys. Thank you so much for listening. You guys have been very patient also. Thank you so much.
Thank you, sir. It was a
Uh,
nice
Thank
session, sir.
you.
Thank you very
Thank
much.
you. Thank you. And no, sir, please. It makes me feel old. Thank you, guys.
Thank you. Thank you.
Thank you.
Thank you.
Kirat,
Bye bye.
it was a good session. It was a good start actually.
Yeah. Thanks, sir. Thank you so much. Cheers, guys. Bye bye.